Hiya folks, this is about geometric. So if you're not sure what a geometric sequence is, have a look back at that first. So a sequence is where you're multiplying by the same number each time. So a geometric sequence would be 4, 12, 36, 108. So what's happening there each time is it's being multiplied. Each term is being multiplied by 3 to get to the next one. So that's a simple enough geometric sequence. A geometric series is where you're adding them together. So 4 plus 12 plus 36 plus 108 plus whatever it is up to whatever one you want. So that's what's the difference between sequence and series. So this is a formula here for the sum, like the sum of the first whatever terms of a geometric sequence. Right, so find T5 and S5 of each of the following. So T5, that would just be the fifth term in the sequence. So I'd go back to the formula that I had before. So that's T of n is equal to AR n minus 1. That's the old one. So I'll just use that just to recap. So T5 would be A here is the first term, so that's 1 in this case. R is the common difference. So what's it being multiplied by? Well, to get from 1 to 3, you're multiplying by 3, and to get from 3 to 9, you're multiplying by 3. So 3 is the common difference, and then n minus 1, so 5 minus 1. So that's just 1 times 3 to the power of 4. So that would be 3 times 3 times 3 times 3. So that's 108. So that's T5. If I'm getting S5 though, that's the sum of the first 5 terms. So that's, I'm using the formula up there then in the orange box. So A is 1, then inside the bracket I do 1 minus R, which is, we said was 3 here, and that's to the power of n, so that's to the power of 5 all over, and then it's 1 minus R, so 1 minus 3 on the bottom. So use calculator then is probably the easiest way of figuring all that out, and so we should get 1, 2, 1 there then. Second one we probably do first always is see what your A is and see what your R is for the sequence before you start. It was easier in the first one, but here we go 1 and a quarter and then 1/16. So it has to be 1 anyway, so that's the first term. R, so what's happening each time here is you're multiplying by 1 over 4. So to get from 1 to 1 over 4, you have to multiply by 1 over 4. To get from 1 over 4 to 1 over 16, again you have to multiply by 1 over 4. So that's our general term here. I'm going to get T5 just be, again I'm using the original formula. T of n is equal to AR n minus 1. So T of, we're looking for the fifth one again, so T of 5 would be equal to 1 times 1 over 4 to the power of 5 minus 1. So that will just break down into 1 over 4 to the power of 4. So that's 256, 1 over 256. Right, so S of 5 then, so this is all of the 5 terms added together. So that'll be 1, putting it into the formula up in the orange box again now, so 1 minus 1 over 4, and that 1 over 4 is to the power of 5 all over 1 minus 1 over 4 on the bottom. And again, calculator is the easiest way of working that out. So we get 3, 1 over 256. So that's what the first 5 terms in that sequence added together would be. That's what sum of geometric series does. So yeah, this is this is sum to infinity then, so it's a smaller, simpler formula. So if I want to get the sum to infinity, that's sequence of what it would add up to if it keeps going. So all I have to do is just put in what they are. So A here is 16 in the series, 1 minus, and then the difference. So to get from 16 to 12, what you're multiplying by 3 over 4, I think. Yeah, so each one is 3/4 of the one before. So 1 minus 3 over 4 on the bottom. So you could do that in your head. It's going to be 16 over 1 over 4, which would be 4/16, which is 64. And just one more example then. That's actually the example we did before.